now we're going to see how ATP is generated from the glucose we just absorbed. So you see glucose has arrived to the muscle cell. This is the cell wall. Okay. You see glucose have 6 here, they have 6 carbons. So the glucose now enters into the cell and undergoes what's called the phosphorylation. So he finds a girlfriend called phosphate which attaches the 6th carbon of the glucose. This guy is called glucose 6-phosphate. The glucose is very happy. You get a girlfriend, you change. The glucose changes to fructose 6-phosphate. Girlfriend still has the 6th carbon. Now what happens to fructose 6-phosphate? Evil sets in. So now he thinks of making 2 girlfriends. So now he has a girlfriend on the first carbon and a girlfriend on the 6th carbon. So this fellow is called fructose 1,6-bisphosphate. But nobody's happy with 2 girlfriends. So even this burger divides into 2. So 3 carbons go here, 3 carbons go here. So this molecule is called the dihydroxyacetone phosphate with a 3 carbon and glyceraldehyde 3-phosphate with a 3 carbon. These 2 molecules undergo a lot of reactions producing ATP to form what is called the pyruvate. Now this pyruvate have 2 pathways. Okay, let us go to the anaerobic pathway. What do you mean by anaerobic pathway? That is, there is oxidation of pyruvate to produce ATP in the absence of oxygen. For example, if you are doing strength training, so you go to the gym, you do your biceps curl and start feeling that burning sensation on your muscles. That is because of the anaerobic pathway. You're not able to send enough oxygen to their muscles. So the byproduct is lactic acid. So that is why you feel that burning sensation. Sorry, not acid, acid. Okay. Now, what about those people who do a lot of endurance training, running, jogging, swimming? So they use this pathway, aerobic pathway, because you have continuous supply of oxygen. So in the presence of oxygen, it forms what is called, in the presence of oxygen, the pyruvate undergoes the aerobic pathway. So this is the mitochondria, or the cell factory where all the energy is generated. So this pyruvate now enters the mitochondria to form something called the acetyl coenzyme A. And then it participates into the Krebs cycle and electron transport chain to form lots and lots of ATP. The amount of ATP formed here is much more than formed by anaerobic pathway. So now we have seen how glucose undergoes all these reactions to produce ATP. So now we're going to see how the body regulates the glucose. So what happens? So when we eat something, especially glucose, so the glucose level in your blood keeps rising. Okay, once it reaches to around 130 milligrams per deciliter, a special hormone is secreted by the pancreas. That's called insulin. Right here, insulin. Okay, now what this insulin does is, it helps glucose to enter the cell and also synthesizes an enzyme called hexokinase. Okay, it influences this enzyme, it influences another enzyme called phosphofructokinase 1. So insulin, it influences this enzyme and tells them to start this process of glycolysis. So what is glycolysis? Turning of glucose into ATP. So your insulin stimulates this process. So now your glucose in the blood is being converted to ATP. Now as your blood glucose level starts to drop, a special hormone again by the pancreas called the glucagon. Glucagon. That means the glucose is gone. It's secreted, and this glucagon inhibits these enzymes and stops the glycolysis, in order to maintain the glucose level in the blood. So this is how a body manages the glucose level. Okay, now we're going to see a case where there's a person who is sedentary and he consumes a lot of carbohydrates in his diet. So he has 6 meals a day and all the 6 meals are comprised of carbohydrates. So what happens? So the first thing, Your ATP in the cell have a limitation to how much it can store. So once your ATP store is full, what's going to happen? This burger is going to come here and inhibit glycolysis. You say, I'm full, I don't need much ATP, I'm already full. Oh, then what happens? Where does excess glucose go? That glucose is then converted to something called as glycogen in your liver. I just mentioned earlier, the glycogen is a polysaccharide, so your glucose gets converted to glycogen, and the process is called glycogenesis. This happens especially in the liver. So okay, good, that's very good. Your glucose, you cannot produce ATP, but it is replenishing your glycogen stores. But there's also a limit in how much glycogen your body can store. So in your liver, you can store around 100 grams, and in your muscles, around 300 to 400 grams. Okay, what if your glycogen stores are also full? Your ATP stores are full, your glycogen stores are full, and yet you're consuming a lot of glucose. What happens now? Now what happens is, you see this molecule here and this molecule here. Now, what these people do is, this fellow converts to something called as glycerol. Oh, very interesting. And this acetyl coenzyme A converts to something called as the long chain fatty acids. And these two combine to form something, combines to form something called the triacylglycerol. It's a triglyceride, it's a fats, and that's stored into your adipose tissues. You see what happens? Your ATP is full, your glycogen is full. And what to do with excess glucose? Your dehydroxyestrogen phosphate and acetyl coenzyme A forms what's called the glycerol and long chain fatty acids. Together they form something called as a triacylglycerol, that's fats. So you're storing the glucose as fats in adipose tissues. Okay, now what? We build another case where you are frequently involved in physical activity. So what happens? You use up most of your ATP, you keep using your ATP. When you use up your ATP, you see, you found that the ATP is converted to ADP. So what happens? When the ATP decreases, your ADP increases. And this increase in ADP again stimulates this reaction and tells the body to start glycolysis, because I am in need of ATP. So you're using the glucose in your blood to produce more ATP because you're a very active person. Okay, now what happens if you're starving for a long time? You don't have enough glucose in the blood, but you need glucose because your brain works efficiently with glucose. So how does your body generate glucose? You see, it can generate glucose from glycogen. So it can store as glycogen, it can take back. The glycogen can convert it to glucose, and this process is called glycogenolysis. Glycogenolysis, that is formation of glucose from a glycogen. Your body can also form glucose from fats, from proteins, and from this lactic acid. This lactic acid can go into the liver and come out as glucose, so lactic acid. You see, your body can make glucose enough for your brain to function properly from glycogen, from fats, from proteins, from lactic acid. This process is called glyconeogenesis. That is, making new glucose. So this is all about your glucose. So we have learned about glycolysis. We have learned about glycolysis, that is generation of ATP from glucose. We have learned about glycogenesis, that is storage of glucose in the form of glycogen. And this process, I forgot to tell you, this process is called lipogenesis. Okay, we don't talk much about lipolysis when we talk about fat digestion and metabolism. We also studied about gluconeogenesis, that is, the body can produce glucose from fats, proteins, and lactic acid. So let us now review what all we have learned. We have learned about glycolysis, that is production of ATP from glucose. We have learned about glycogenesis, that is formation of glycogen from glucose, which is a storage form of glucose in the body. We have learned about glycogenolysis, that is formation of glucose from glycogen when a body needs glucose. We learned about gluconeogenesis, that is formation of new glucose from fats, proteins, and lactic acid, that is when a body needs it. Then we learned about lipogenesis, that is formation of fats from glucose. So now we understand how our body regulates glucose and what's the importance of glucose in a body. Today there are a lot of videos on YouTube which says that carbohydrates are bad for our body, they make us fat. But it's not carbohydrates, it's being sedentary and consuming a diet in excess of carbohydrates. We have already discussed how glucose is converted to fat in excess. So let us talk about, let's take an example of an athlete. An athlete, he has trained his body to convert glucose to ATP, whereas a sedentary person has trained his body to convert glucose to fat. So if you cultivate this habit of engaging in physical activity for a long time and make it a lifestyle, you will definitely transition from this level to this level. That is all I want to tell in this video. So if you like this video, please click like, subscribe to my channel, and please comment. Your comment will encourage me to make more of such videos. Thank you.